Okay, what we're moving on to, perfect squares and cubes. So, we need to know a few things pretty quick. All positive numbers have two square roots. They have a positive square root and a negative square root. Get some confused looks. So, if you did the square root of 4, it's equal to 2. Why is it equal to 2? Because 2 times 2 is 4. That is true. So when you take the square root of something, your answer multiplied by itself should give you this number right here. So would it not be true if we did negative 2 times negative 2? That's also equal to 4. That's why all square roots have two answers. Because your negatives will just cancel each other out. So every time you guys take a square root, your answer needs to be positive and negative. You cannot take the square root of a negative. Why? What? Emma, go ahead. Right. Because a negative times a negative gives you a positive, and a positive give you a positive. And if you had a negative and a positive, then you're not doing the same thing. So it obviously isn't going to work. So, the square roots of a perfect square are rational numbers. Perfect square. You need to know what that means. Those are numbers like this 4, 9, 25, yeah, Matthew? Because when you take the square root of those numbers, they give you a rational number, like 4. What's the definition of a rational number? Hand up. Yeah. Yeah, exactly. Decimals that terminate or give you repetition, right? So the square roots of non-perfect squares, like 17, are irrational numbers. So punch in your calculator square root of 17 and check out what you get. What is it? Who's got it? What is it? Do it again. 4.12 what?
Perfect square is a number that squares up, right? That word rational number can be a decimal.
Yeah.
That's not square. Perfect square is a number.
Yeah. Yeah. You're right. So Liam's got a point. We have rational numbers. That's what we said perfect squares are. What are they actually, Liam? Right, and what kind of number is that? Whole number. Those are our whole numbers. So when we're talking about 16, 25, 36, those are things when you take the square root, give you 3, 4, 5, 6, and so on. I do not. You get those after. You're going to need to know some quick perfect squares. It's going to help you. Here's some tips for your calculator. Those of you who have big fancy calculators, these are how you do square roots and cube roots and other types of roots. These are for your reference. Those of you who do not have the big graphing calculators, you're going to have to figure it out on your own calculator until you get one of those other ones. Please, you need the graphing calculators. I've said that a few classes now. You need to talk to your parents. Ladies, you guys need to talk to your parents and get a hold of one of those. It is critical for later on, because Liam, what's one of the hardest units we do? The graphing unit. And what do you have to graph on? On your calculator, right? You don't have a calculator, you can't do the entire unit. So, get your graphic calculator. Yes, Josh?
When you, okay, good question. Is this, like, if you press this button and press...
I'll help you out after, okay? I'll come help you. Yeah, I'll come see it and help you out after. Boys in back. It says, can fractions be perfect squares or perfect cubes? What do you think? Yes? No? Yes? There's two examples on the bottom. But before we can do those, we need to remember a couple things. When you are doing this, and you have a number here, which they call x, a number here, y, the square root sign applies to both the x and the y. So you need to do, if you're doing it separate, you need to remember it does like that. If you punch in the fraction first and then do the square root, that's also okay. Okay, what's your answer for this one? The square root of 25 is?
The square root of 25 is 5.
And 7. What's the next one? Try it. Square root of 36 is? Square root of 47 is? Six divided by? 6.85. Do we agree with that?
Oh, yeah.
Oh, yeah. So, can fractions be perfect squares? They can be. They aren't always.
Don't you, when you do like all squares like x and stuff, don't you, you're not going to divide that because technically it's not perfect square, it's divided by the 7.
Right, so if we had mixed up my definition of perfect square with what I consider a perfect square, which is the issue. So, the definition we're working with is it comes out as something you can write as a fraction. Sound good?
Yeah.
All right. Estimate the value of whole number. So, we need to talk about estimations. Estimation means you need to do it without your calculator. Talked about this earlier today, right? So, how do you estimate something without your calculator? Josh?
So, what you do is you get the closest value to that and put, like, get perfect squares that are round, like, that look like they're around that number.
Right. Which is why I was referring to those other things incorrectly as perfect squares. But yeah, it's knowing those easy whole numbers that come out. So, square root of 46. You would use the square root of 49 and the square root of 36. Now, why did you pick those numbers, Matthew?
Because that's
Because that easily comes out to be 6, and that easily comes out to be 7. So then he can take a guess at what the square root of 46 would be. 6.5? Probably a little higher. 6.5 means it would be directly in between 36 and 49. But 46 isn't quite directly in between those two numbers, is it? Let's say 6.7. 8. Wow. So, I'm going to give you guys a test where you don't have a calculator. Not right now. And you're going to have to do this. So you can't just put it in your calculator and then guess. Does that make sense? No? Okay, let's do one more together.
Isn't it the nearest whole
This is to the nearest whole number, so you would go up to 7. Let's do this question in another way. So the way that these guys looked at it was they knew these things here off by heart. What we're going to do is fill in this side chart as a reference point. So 1 squared is 1, 2 squared is 4, and so on and so forth. And you guys can fill in this entire chart. Keep going. What's 11 squared?
Oh, 21.
And then what's 13 squared?
12.
160?
Oh, 169. 12 is 144.
Yeah.
That's right.
60.
Yeah. And 14 and 15?
225.
196. 225. It's hard to write this. Alright, you three, you need to cut it out. Okay? There. Nice and simple. Done. Next time, just get out. Make life easy? Yeah? One of you's answering.
Yes.
Good? Yeah? Okay. What you're going to do is you take that number that you're doing the root of, and you're going to look for it in this column. And whatever it's closest to, that's going to be your hint for your point. So it's a different way than these two up front did it, but it'll still get you to the same point. So what's 5 closest to? Obviously right here, right? The 4. Just 4. Because it's closest to 4, means it matches up between one of those two numbers. Which one would you round to if it was the nearest whole number? You go to 4. Why wouldn't you go to 3? Because 5 is closer to 4 than 9. Okay? So we can estimate this to be negative. Negative sign is over here. I'm not sure if you can see it in your notes, but that is a negative sign. It might blend in. It's going to be negative. And we're going to go 2.2. And since we're doing whole numbers, that's just negative 2. Okay? Try the next two together. There's a couple tricks to these ones, so give them a shot. This 2 in front, what do we call it? It's got a definition. It's called a coefficient. What do you do with coefficients? You multiply them to this once you've answered it. There's a negative sign right here. Oh, great question. Matthew has a question about B. He says you can't get negatives. The negative is in front of the root sign. So it doesn't apply to it. You can't do a negative underneath the root sign. It's in front though, so it's alright. So it almost acts like a coefficient would. These coefficients down here, imagine that's just negative 1 multiplying by. It would be negative 2.2 if we were estimating it, but we're estimating the nearest whole number, so it's negative 2. Do you have a question? If you could do that, yeah, that's what we're doing in a couple of days, but yeah. If that makes sense to you, yeah, that would work the same way. Still confused? The first thing you need to do is you need to estimate the square root of 18 and the square root of 37. So give that a shot. Talk to your partner if need be, or talk to someone near you.
I don't even know what to say. What do you think?
Okay, so now you go. Yeah, and then try for 37. But just right. Okay, but you wouldn't know about this. We're not a bad thing. I thought you ate long. But you're not supposed to have it for turn it on after.
Shoot me, I'm still guessing. No, I know it. What do you feel?
Yep. Yeah, it's all fun.
Done.
Okay.
I like putting it back. You can do it now.
Alright, let's do this as a group. The question as a group. Just a second. Boys. Yeah. Okay, ladies and gentlemen. So what you had to do is you had to estimate this square root and this square root. If you estimate the square root of 18, you look at the number 18. Where does it fall in between? It falls right here, which means the square root of 18 is going to be somewhere in between there. 4 point something, right? It's closer to 16 than 25. So we're going to say 4.2. The square root is 37. Where does 37 lie? There, right? Yeah. Which means the square root of 37 would be in between what? It'd be somewhere between the 6 and the 7, and it's closer to which one of those things? 6. 6.1. People are asking, what do we do with these numbers? Right? We still need to have them there. So this number right here, 4.2, Multiply it by 2. Multiply it by this coefficient. It's still hanging out, so that's 8.4. And this 6.1, you have to multiply it by 5. You add those two numbers together, this addition sign hasn't gone anywhere. 38.9. Yeah, that's when you're converting. Yeah, you're getting ahead of us. Yeah, that's for when you're trying to convert it into an entire radical. This is just estimating. Yeah, you just leave it on the outside. Matthew.
Why is there two squares on the 95?
For the next one? We'll get there in a second. Anybody have a question about C? D. It's tough to tell, but there's two square root signs. So take the square root of the square root. So you're going to estimate the square root of 95, and then you're going to square root whatever that estimate is. Square root of 95.
9.8. 9.7.
People are saying 9.8, 9.7, somewhere around there, right? 9.8. But we still have one more square root left. What's that going to come down to be?
3.6. 3.4.
How'd you get that?
I think it's 3.6.
It's educated guessing. That's what estimating is. How do you think you get it?
I think it's because you got the square root like what you estimated.
It's not just guessing. There's a reason to where you're guessing. Where's it coming from? Someone put their hand up so they can explain it. How'd you get that? Okay, what did you look at? Yeah, so Aiden's saying he's looking at these two numbers right here. He knows that 9.8 is somewhere between those two numbers. It's closer to 9, so he's estimating that's closer to 3. So he went 3.1. Oh, 3.0 something. He was a little more precise. 3.1, 3.08, whatever he estimated. 3.2, those would all be good answers. Okay, so we need to do a couple quick things review-wise. How do you calculate the area of squares?
Count them.
You count them? So how would you count this? Okay. Length times width, right. I lost our little side thing. So yeah, your length times your width. In a square, the length is equal to what? Your length is equal to your width. So it's the same thing, right?
That's a nice pick.
Thanks, from Pam. Cool, dude.
So
Question? No? Okay. So when it says the area of a square is 36 units, and it says what's the side length of the square? How do you find? You take the square root. Why do you take the square root?
This is a square.
Because it's a square. Because area is equal to the side lengths times each other, right? But in a square, they're the same, right? So side times side. The area is equal to side square. So if you wanted to find just one side, you have to take the square root of it. Which means you just take the square root of the area. Is equal to just one side. So, what's the side length of the square? 6. Determine the side length of a square if the area is 20 units. Round to the nearest 100. It's asking you to estimate. So don't use your calculator. Four? We got an answer of 4. Who agrees? Around 4. You agree? 4 point what? 4.5? 4.7? 4.5? What two numbers is 20 close to that are squares that come out to nice whole numbers? 16, 25. Look at your chart on the other paper. Which number is it closer to? Yeah, Carter.
5.
It's closer to the 4, right? Closer. Carter says it's closer to the 4, but just barely, right?
Yeah.
So then what are you going to put, Carter? What's your answer going to be? Side conversations need to stop now. Last time. There. They're done. We're trying to hear an answer from the back. If you guys have a question or comment, put your hand up. I'd be happy to hear it. Carter. 4.4, because it's a little bit closer to 4, but just barely, right? Cube roots. We're doing the same thing now, but it's with cubes. On the side, write down, we're going to do a quick chart here. So have your calculators out, fill it out quickly. Do it on your own. Once you do that, use the same techniques we just used to estimate. Examples. It's cubes, right? It's cubes, it's not squares. What's the difference? The cube is 3 times 3 times 3. So 3 cubed isn't 9. You didn't need a calculator. If you're done, check with the person beside you. See if you got all the same answers. I see some different ones. Your answer should be the same as the ones up on the board, and you should be moving on to estimating those examples. Use the same technique. You're going to look at this number, 11. You're going to see where it falls in between. 11 is in between 8 and 27. Which one's it closer to, Joe? 2. It's closer to the 8, so it's closer to the 2. I'm going to say 2.1 through 2.3. Those things will all work. Question? Yes. Right. 120, what's it fall in between? Where's 120 fall between? 4 and 5, yeah, because it's in between here and here. Which one's it closer to? Closer to our 5. And it's way closer to our 5, right? So what's our answer going to be? 4.9. 4.9 works for me. It's asking you to round to the nearest whole number. So this one would drop down to 2. This one would go up to 5. How did I do that? I took this number right here. Matthew? Oh, you did the other one. Do C with a partner if you need to. Figure out what 70 comes close to. Notice that this isn't cube root. The first one's not a cube root. It's a square root. What's the square root of 70 close to? What is it? 8.1. The 4 is still here. And the 70 is close to what? Let's do 4.15. And you're going to multiply that by 4 still. I switched the 4 over because I was running out of room. The order doesn't matter on multiplication. And then what's your final answer if we go with these estimations? $15.8. Who agrees? 16? Because your estimations are going to be just close, right? 16, 15.8. Very, very close. Comes down to your estimations. So if we did 15.8, it would round to the nearest whole number of 16. All right, we're almost back onto our assignment, guys. Volume. A cube has all side lengths equal. How do you calculate the volume of a cube? Yeah. The volume of a cube is equal to this side length times this side length times this side length. Length times width times height. In a cube, those things are all equal to each other. Which means volume is equal to all those sides cubed. So if we wanted to figure out the side length of just one, yeah, Carter? It'd be 6. Yeah, how'd you do that? Because you did cube root, right? Which means cube root of 216 is equal to, Carter already said it for you. Nope. Not for this. Later on you will. Cube root of 216. 6. Do the bottom one. The volume of a cube of 100 units. Determine the side length. All we want is one side length. How do you figure out a cube root? So where's your list of cubes? Remember that list we made? You should have made this chart. So you look at what's underneath the root side. Nope. This one you're estimating, no calculator. So, see where I put that X in the question mark? So you need to look at that number and see where it falls on your chart, on your answers. What's it fall in between? When you do this question, what's underneath the cube root? This is, guys, this is a hard question. It's gonna stump you guys when you see it on your assignments. Yeah, just so we got some. I know you got it. Why do we do the cube root of 100? To figure out the side length. I don't want you to just do it automatically. I want you to know why you're doing the cube root of 100. Because when this comes up on a test, it's not going to be automatic in your brain to just do the cube root of it. It's automatic right now because we've been talking about it. You need to know the actual reason. You can just make the chart anytime you want, right? You did it yourself. Yeah, I make the chart for a test for something. We did it because of this stuff over here, right? This. That's why we cube rooted. Yeah, Johnny. Yeah, you gonna answer that?
Yeah, but I think it's wrong.
So we did the cube root of 100. And what's the answer?
4.6.
Carter?
4.6.
4.6. Thanks, Carter, for putting your hand up. The volume of a cube is 729. Determine the surface area of the cube. What kind of information do you need to solve surface area? What information do you need to solve surface area? Carter. Length times width, so you need to know the side length before you can do anything. Somebody else, how do you solve the side length? Emma. Cube root 729. Because all side lengths are equal on a cube. You got the answer? Okay, just wait. Thank you. You okay? Are you? Bored. All right, Carter, step us through it. Which is equal to one side length, right? Does everybody agree up to this point?
Yeah.
All right. Area, surface area, equal to length times width. The length and the width are the same length of the side, right? So what's surface area? 9 times 9? 81. 81 what? Centimeters square, not cube, right? Cube is cube because it's volume. We multiplied 3 things, right? Especially in the back. Yeah. Yeah. Is that what you're going to say? So, what's this, the surface area? Just one side. So if we went back, that's just this surface area. We want the surface area of the whole cube. So what do we have to do? Y6. Joe, Y6. Oh, okay. Yeah, there's 6 sides of a cube. Thank you, Emily. It's squared because we did one side times another side. So it's 2 things, right? It's cubed when you're doing volume because you're doing 3 things. So, the surface area of the whole thing is 81 times the 6 sides that we have. And what's that equal to in the back? And your name is Eric?
Yeah. 486.
Pardon?
486.
486. Who agrees? We're close. 486 what? Centimeters squared. Your units do matter, guys. The hardest thing to do in marking tests is to take marks off for some simple things like that. The library has new books on the shelf. The new books come in 2 different colors. The 5th book and every 5th new book is yellow. And the 17th book and every 17th new book is blue. There's 600 books. How many of the rows have both blue and yellow books? Confusing, eh?
In this question, there's basically one shelf.
One shelf.
So,
Yeah, and there's 600 books. How many of the rows have both blue and yellow books?
just 3.
But it doesn't tell you how many in a row, does it?
So there's basically 600
Yeah, so it would be
3.
how many blue books and how many yellow books. Yeah. We'll do that